Hi, in this lesson I want us to work through the mining hazard study task. For this lesson you'll need the study task sheet and the questions that go with it. Okay then, let's go. The first question actually relates to figure 2. So figure 1 shows us a cross section through an area. We'll talk about that in a moment. Figure 2 here is a graph looking at rock strength measured in megapascals. First question, have a go at completing that graph. Secondly then, can we try and explain what's going on within the shale? Okay. Fairly straightforward questions. Questions 3 and 4 then, look at this cross section. We've got an old pillar and stall mine that's been subject to subsidence in a couple of different locations. But you can see that subsidence isn't uniform. So what I'd like you to do is first of all explain why location A hasn't subsided. And then I'd like you to explain why location B has subsided. Use the geology and crucially as well use the graph that you've just been working on. The final question on this is a bit more open, a bit more general. Think about the work we've been doing, looking at the different mine hazards. What else, other than subsidence, might be happening with these abandoned mine workings? Notice in the question it says hazards. You need to be talking about several of these. But there's quite a few ways you can get those 5 marks. You could go for breadth or you can go for depth. But think carefully about your answer and make sure that you've got enough information in that answer to justify all those marks. Okay, have a go at those questions now, see what you can come up with. Okay then, let's see what you've found. So the first question asks you to fill in the graph. A really straightforward question. Should be some very easy marks to pick up here. Okay. Give yourself a mark if you've got the very low value in the shale. Another mark then if you've jumped up into the coal. The third mark then is for showing the very high value in the sandstone. Easy marks. Question 2 then asks you to explain this change in rock strength within the shale. Now, by looking at this graph, it should be pretty obvious. First of all, we have to describe it. So we go from moderately weak rock down to a weak rock, from 20 to down to 5 megapascals, or if you want, or the other way around if you're looking at it from the bottom up. So reserve mark that, you need to have some description. The explanation is clearly related to the water table. That change happens at the water table. Above the water table, the shale is stronger, below it's weaker. Wet shale then is going to become more ductile. It will start to flow. You can see that on the cross section where you actually see some what we call pillar punching, where the pillars have pushed into the weak shale below the water table. And that's a result of poor water pressure. We've talked about that quite a few times in the course. Poor water pressure will reduce the cohesion between grains within the shale. So there's 1 mark for describing there and the other 2 marks for explanation. Question 3 looks at location A. Now this is above the area where the section is. 4 marks to try and pick up here. So we've got dry pillars here that are above the water table. So we don't have erosion or weakening of the either the rocks in the pillars or the shale underneath the pillars by water. The pillars here must be big enough to support the weight of the overlying rock. We can see at A, it's perhaps not as much overlying rock as there would be, say, at location B. There's also a roof of the mine here of sandstone. And this sandstone, which we can see from the graph, is stronger. It's much more competent than the mudstone. So if we've got a sandstone roof, that's going to be stronger. Clearly, the zone of subsidence to the left of location A doesn't have that sandstone roof, which is one of the reasons the rocks there have collapsed. And finally then, the shale in the floor of the mine there is above the water table. It makes it stronger. You could talk about the weight of overlying rock as well, but those are the 4 real key points that we're looking for. Question 4 then looked at an explanation for the substance at location B. Now for location B, we can see the water table having an effect here. It's going to have an effect on the strength of the underlying shale. We can see the shale there is contorted. The coal pillars have pushed their way down into that shale, and the shale has flowed up into that void space. Because it's ductile, so it's flowed. Got the coal pillars sinking, or pressure pillar punching is the name for it. And the sandstone above here isn't quite strong enough to support perhaps the greater weight of mudstone above location A compared to location B. Although we can see it's sort of deformed a little rather than completely failing. And finally then, question 5. The geological hazards other than substance that can be associated with these abandonments. There's a lot to go at here. You need to give at least 2 hazards, and you need to describe them in some more detail. There are a number of ways of picking up the marks here. You could briefly describe 5. You could pick 2 and really go to town on them. You could give examples of these where these things have happened. The key thing with a question like this is to make sure your answer is big enough to allow the marker to give you all 5 marks. Don't skimp on your communication for an answer like this. Okay then. If we draw some conclusions, mining clearly presents a whole host of hazards. It's not possible to learn every single one in detail for any examination. What's really important to do is to try and use the data that you're given carefully and applying your geological common sense to it. Applying geological principles to the situation that you're dealing with and the type of data that you're dealing with, whether that be a map, a graph, cross-section, to try and work out what's going on. We do need to think about some other anthropogenic hazards, but that's for another lesson. I'll see you then.